Welcome to today's SliceNet webinar series. Today's webinar is on cross-plane orchestration and use cases prototyping. My name is Jeanne Louise Caffrey of RedZinc in Ireland, a partner in the SliceNet project, and I will be your moderator today. Today we have a very interesting webinar from SliceNet with our presenter, José Cabasa. José is a networks systems architecture engineer in the technology and innovation strategy in Altice Labs, or Portugal Telecom, and he is based in Aveiro in Portugal. José graduated in engineering from the University of Aveiro in 1990 and has extensive experience working in telecommunications for Portugal Telecom since that time. He started in the digital transmission product development department, developing digital multiplexer exchange equipment. He has worked in installations and deployments in many countries, including Portugal, Cape Verde, Sao Tome, Mozambique, and Morocco. He also has an internationally recognized training certificate with the IEFP and gives courses in all these countries in the telecommunication areas of PDH, SDH, XDSL, optics, and IP. He is currently working in networks systems architecture with a special interest in software-defined networks, network function virtualization, network slicing, and 5G technology. With all this expertise, José has been leading the work in SliceNet on cross-plane orchestration and indeed on standardization, and we can now look forward to an informative session on these topics. The purpose of today's webinar is to present the technical achievements and innovations focusing on end-to-end network slice orchestration. We will have time for questions halfway through and at the end of the presentation. I will keep an eye on the chat box so that if anyone wishes to ask a question or make a comment, please feel free to type into the chat box and I can bring this up at the end. So for now, please enjoy the presentation, and I will pass you over to José.
Okay, thanks, Jen. Welcome and good morning to you all. Today, the SliceNet webinar will be, as Jen said, about the cross-plane orchestration and use cases prototyping. Just small instructions that you already know: to mute your microphone, send your questions via chat, and as you know, the session is being recorded. The webinar purpose is about the disseminations of SliceNet technical achievements and innovations on the orchestration plane mainly. And the webinar agenda, these are the topics that we'll address in the next few minutes. So we'll start in the brief introduction, the business roles in SliceNet and also mainly in the standardization bodies, SliceNet architecture and application plane, challenges and requirements, and then we go in a deep dive in orchestration in DSP, in NSP levels, the technical achievements and prototyping, and also an example of what happens with orchestration when a vertical subscribes a service, summary of innovations, and question and answers in the final. This slide has been presented in the previous webinar, so I will not waste your time with it. Just remind you that SliceNet focuses on management of network slicing by use of cognitive techniques. So just highlight this phrase in this slide. So let's jump to the SliceNet business roles that we have identified in the project. As you can see in the figure, you have the NSPs, we call it a network service provider. In the NSP, it's the player that has the network infrastructure. So it will be the NSP that will build on top of this infrastructure their network slices. And each network slice will have special requirements, either low latency or high bandwidth, and so on. So each one of them will make their network slices and will offer them to the DSP. The DSP is what we call the digital service provider. The digital service provider will grab every one of these network slices that he needs, and will compose an end-to-end network slice. This end-to-end network slice, it will reflect kind of service that he will offer to the vertical. This service will have special requirements according to the vertical needs. So mainly this is the three major players that we have identified: the vertical, the DSP, and the NSPs. Of course, when we started the SliceNet project, we were looking for what was happening in the standardization bodies, and mainly we were focusing and looking carefully with what is happening in the 3GPP, because they were already starting with some recommendations in the network slicing. And they have this technical report 28801 that makes recommendations on management and orchestration of network slicing, and they have there, among other things, this figure which relates to the high-level model of business roles. They identified several players, and as you can see here, they have the communication service customer on top, the communication service provider, network operator, a virtualization infrastructure service provider, a data center service provider, and so on. So they have a more granularity, let's say, of players, but we can map our SliceNet business roles in this 3GPP business roles. As you can see here, usually the network service provider, it's for instance, is a telecommunications operator that have all this infrastructure below. The network operator has also the virtualization infrastructure, the data centers, and so on. It has the hardware, usually. So it will be the network service provider that will make the network slices to the digital service provider, that in the 3GPP they call it communication service provider. And then in the end we have the vertical, which is the consumer, the communication service customer that will consume the end-to-end network slices or services, as you like. So we are very aligned with these 3GPP business roles, and later, more recently, IQT also released recommendation Y3103, which defines also the business roles from the network slicing perspective, and they have this figure with the business roles where you can see also in a different granularity again, but you have the network slice service user on top, the network slice service provider, network slice provider, network infrastructure provider, and then they have separated the management and orchestration providers. But again, in this figure, you can map what SliceNet proposes, which is the NSP. So the NSP, in this case, it will be the network slice provider and the network infrastructure provider, and also the management infrastructure provider and the management and orchestration of the network slices that are on the right side. So it will compose network slices and offer them to the DSP, which is the network slice service provider. So the DSP will compose into network slices and offer it to the vertical or network slice service user. So these are the different way of presenting the business roles, but overall we can see that there is a mapping, there is an alignment between all the three, SliceNet and the two other main organization bodies in telecommunications right now for the network slicing aspects. So now let me just go to show you what we have in a SliceNet architecture regarding these three players that we have seen before, the NSP, DSP, and vertical. This figure it's a little bit dense. It has a lot of information, but I will try to make it simpler and clarify it. And let's see what's happening in the network service provider, the several planes that we have identified, and also we can see highlighted there the orchestration building blocks. We have the service and slice orchestration, we call it SSO, and we have the resource orchestration that we call it NMRO. So you can see in yellow, you can see that you have below you have, of course, all the infrastructure. This is the NSP, so it will need the infrastructure, the network plane, with all the equipments, different equipments from different vendors, with virtualization and physical equipments also. And on top of it, you have the monitoring plane. The monitoring plane is grabbing all the information, all the alarms, events, counters that all the equipments in the infrastructure are providing. So this monitoring plane will, at runtime, will persist this information in the information plane, in this data lake, in this database that you have here, and we'll also send it to the aggregator, but we'll talk with that a little bit later. So, as you can see here in the information plane, also you have, besides the data lake, which is making the historical information about the alarms, events, and counters, you have also an important part, which is the catalogs. The catalogs are the network slice offers to the upper layer, in this case to the DSP, and also the resource catalogs. And of course, when we instantiate a network slice, we'll have the instances in the inventory. So what is running, up and running in the NSP, which will be part of the inventory in the information plane. You have here also the cognition plane. This is a very important plane for us because it will give us the possibility to make alarm predictions and to act on the network in order to prevent failures. So just a brief explanation of what's going in this cognition plane. You have here the aggregator, which is a component that will gather the information from the monitoring plane and the data lake. With this aggregator, will make the consolidation of this data. This is a lot of data, maybe some of them is repetitive, so the aggregator needs to consolidate this data, eventually make new metrics out of this data, and will send it to the analyzer. The analyzer is where we have the machine learning models running, and these machine learning models will, based on that inputs from the aggregator, will predict an alarm event, for instance. And this event will be forwarded to the RUTAL engine that will check the conditions that exist on the policy manager, and with that event and the conditions that are there, he can realize that he needs to make, as a mitigation action, something, for instance, increase the bandwidth or replace the network slice, whatever. And after, what this component will do in the policy framework, it signals the service orchestrator in order to actuate on the network to increase the bandwidth or to replace something. So this is just a brief introduction of how it works, the cognition plane. And now, as I said before, the orchestration plane is essential for the provisioning, the initial provisioning of the network slices, and also for the runtime and when there is need for optimization of the network slice. It will be these two orchestrations that will take part in that role. But we will come that later to more detail about these two ones, orchestrators, the SSO and NMRO. Also, you have here the control plane, which functions as an abstraction layer. You have here all these adapters that can make the adaptation layer between the specific equipments that we have from the vendors in the southbound interfaces to the common plane inside of the SliceNet architecture. Also, you have here the service access plane, where we have this, we call it the one-stop API, which is the interface to the DSP. So the DSP sees this also as the interface to interact with the NSP. And that interactions, as you can see here, will be the network slice offers from the NSP to the DSP. And also you can see that after the DSP, if he wants, he can subscribe one network slice, and that will arrive to that subscription will arrive to the service and slices orchestrator, and you start provisioning the network slice. Then you also you have here on the left, you have here the network slice policies onboarding. This is done by the administrator of this NSP that needs to onboard the policies, network slice monitoring, and network slice alerts that come out from the rule engine. So this is just a brief introduction of the NSP architecture in the SliceNet, and what we intend to do is to have as much as we can an autonomous control loop network, and this way we can, based on this loop that we have here, we make the sensing of the network. Then, as I explained before, in the cognition plane and using machine learning techniques, we can predict alarms, and we can prevent them to occur by activating on the network and mitigate that problem. Of course, there are some alarms and some situations in the network that we cannot predict, and they happen, and you don't have time to activate. But hopefully, with this loop, we can, in most of them, and hopefully in most of them, or if not in some of them, we can predict and we can activate in time and solve the problem. Now let's go and see what's happening in the DSP. As you can see, the DSP is very similar in terms of blocks to what we have in the NSP. In here, you have also the monitoring plane. In this case, as the DSP don't have infrastructure itself, what the monitoring plane will do is monitoring the requirements that are in the network slice. And this information will be persisted in the data lake, in the information plane. Also in the information plane, you have the end-to-end network slices and also the inventories. And again, the same principle in the cognition plane: the aggregator, the analyzer, the QoE optimizer, policy manager, and so on, playing the same roles as I explained before, but now in the DSP level. You can see here that the DSP will offer its end-to-end network slices or service, as you like, to the vertical. And the vertical will subscribe the service, and this request will arrive to the service and slices orchestrator, and will start making the provision of the services. So we have here also the end-to-end network slice policies onboarding, the monitoring, quite similar to what we have in NSP. What we don't have here is, of course, the control plane, because we don't have infrastructure. We don't need to make adaptations here. So, but again, we can, in this DSP, we can have the same approach, and we can make prediction of alarms and activate in order to prevent the failure. So we can make the sensing of the network slices, and we can, if certain network slice is not behaving according to the service level agreements, for instance, the latency or the bandwidth is not good enough, we can replace the network slice by another. But that decision will be taken in the cognition plane, and then we can activate with the orchestrator and try to find in the market a new NSP that provides us the proper network slice with the requirements that we need. So this is just a brief introduction to the architecture, and in order for you to see more clearly what we have done and where are the orchestrators, and how in a simple way how they work. I don't know if you...
So we have a couple of questions there, José, if we could just stop for a moment.
Yeah.
And thank you for that excellent introduction to the architecture, very clearly explained. One question is, what kind of monitoring is done at the DSP?
Okay. In the DSP, as you can see here, the DSP doesn't have infrastructure. What the DSP is doing is composing a service based in the offer of the network slices that each NSP is offering below. So these network slices, they have special requirements. It's a network slice with low latency, for instance, or with a certain bandwidth, and the DSP will monitor if the bandwidth is according to what was agreed between the DSP and the NSP or not. So the monitoring in the DSP has to do with that, with checking if the KPIs that were agreed are correct, are accordingly or not, and then it can take actions upon that.
Okay, very good. Can you explain more about the sensing and actuation? What is happening here?
Okay, maybe it's better to go to the NSP. The sensing and actuation, and also the machine learning model that we have running in the cognition plane, they make all these three make all the closed control loop in order to prevent failures in the network. So sensing is essential for us to see if some network element is performing accordingly or it's having a bad behavior with bad performance, and that network element can cause an impact in the network slice, and then the service of that network slice will not be guaranteed, and so all the end-to-end service to the vertical will be compromised. So we need to actuate in order to prevent that network element to continue to perform badly in the network. That's just an example of this can work. Another thing is, for instance, we have some kind of congestion. We have the bandwidth is not according to what it's needed, so we can detect that, and we can have mitigation actions to solve that problem. So this sensing and actuation forms part of the closed control loop that we implement in this architecture.
Very good. And then another question, during runtime, does the vertical experience service disruption or degradation in the optimization processes?
Well, if we can do the prevention of the alarm, it will not sense any problem because we have time to do it. But if it is something that occurs dramatically and the service will go down, then it will experience. But the objective of this closed control loop is to detect and make the alarms predictions in order for us to have time, for the network service provider to have time to act in the network, prevent the failure in order for the upper layers don't see the problem. So usually the DSP and the vertical will not sense any problems if the NSP can correct these prediction failures that were detected in the cognition plane.
Okay. And just one last one here in this part of the presentation. Which parts of the orchestration plane have been created by SliceNet?
Well, we have the vertical slicer. It's a tool from a partner of the project that will make the provision of the slice, and also we have the resource orchestration that will make the provision of the network services resources for the network slice. But I will explain that in more detail later.
Okay, great. Very good. If you'd like to carry on, and if anybody has any further questions throughout the presentation, just pop them into the chat box and I will ask them to Jose at the end of the presentation. So take it away again.
Okay, let's go to this next one. So let's go and now talk a little bit more in detail about the orchestrators. So what were the challenges that we faced during this implementing the orchestration in SliceNet? So one of them was the DSP ability to provide services to the vertical, and this service will need dynamic orchestration, essentially because maybe we can need optimization, for instance, when we have that failure prediction events, and configuration and customization for both single and multiple administrative domains. Another one is NSP ability to provide network slices to the DSP, also with this dynamic orchestration, configuration, and customization. Also, the interoperability between the DSP SSO and the NSP SSO, and inside the NSP, the interoperability between the NSP SSO and the NMRO, which is NFV mechanism orchestration. Another one is the contribution to closed control loops automation networks, enabling the service providers to guarantee the service level agreement without human intervention. So we want to do this as much as we can with this architecture. So in terms of requirements for the orchestrators, and we have here in this figure the DSP SSO vertical service lifecycle, the NSP SSO network slice lifecycle, NSP and MRO resource lifecycle, 4 phases. So we have the discovery, the fulfillment phase, the assurance, and the decommission phase. So for the DSP SSO, in the discovery phase, so the DSP needs to offer services to the vertical, so to expose APIs to the vertical for them to have access to a vertical service blueprint, and also the vertical can, in some parts of this vertical service blueprint, can fill some parts of it like requirements. For instance, the vertical wants bandwidth X or wants the latency Y, so it can preempt, it can fill in some parameters. Another one is the network slice offers collection from the NSPs. So the DSP needs to collect the network slice templates that are offered from the NSPs and store them in these catalogs. And also the VSP, the vertical service blueprints, and the vertical service descriptions onboarding. In the fulfillment phase, the SSO needs to expose CRUD operations on vertical services, because a vertical may want to modify or may want to terminate, for instance, the service. So it will need to expose this to the vertical. Also expose CRUD operations on end-to-end network slices, translation of vertical services into network slices. So it will need to go to the vertical service blueprint and find the correct network slices that he has grabbed from the network service operators to match the requirements that the vertical wants, the end-to-end latency, for instance, or the bandwidth needed. In the assurance phase, as you will see, it's all about the management isolation of the service, management isolation of the network slice, and about the monitoring of the services in the network slices, as you will see. The decommissioning phase, which will be about the termination of the vertical service instance, or about the network slice termination instance. So it will be with the termination phase of those instantiated services in network slices. The NSP SSO in the discovery phase will offer network slices to the DSP, and we will onboard the network slice descriptors. As you can see, there is a pattern here in terms of producer-consumer. And again, in SSO, we have the exposed CRUD operations for network slices, translation of network slices into the network services that we will need and configurations that we will need, provision configuration of network slices, and network slices quality of service configuration. Assurance phase, the management isolation and the network slice monitoring, the commissioning phase, when the network slice instance is terminated, we need to terminate, and the monitoring activation, notification that the network slice is terminated, and so on. For the NMRO in the NSP, network service offer exposure to the NSP SSO, network service descriptions in the resource association, expose CRD operations for network services. Here, network service is a set of VNFs and PNFs that belongs to the resources, to the NMRO. Provision configuration of the virtual network infrastructure associated to network slice, and in the assurance phase, the management isolation and the monitoring of the network services and resources. And finally, the decommissioning phase, terminating the network services and monitoring the activations. So as you already see, what we have in terms of orchestrators in the SliceNet, we have the orchestration for orchestrator, slice and service orchestrators, it's the name for the DSP. And in each NSP, we will have the service and slice orchestrator and the NMRO and NFV mechanism orchestrator in each of them. Let's talk a little bit more in detail about these ones. So the DSP SSO provides the following functionalities. As you can see in the right side of the figure, you have the REST APIs in the northbound interface to communicate with the vertical. You have the communication service APIs in the southbound to communicate with the NSPs, and in the middle we have the main services provided by the SSO. So the vertical service manager, end-to-end network slice manager. You have also the catalogs, the VSP, the VSDs, and the network slice templates that were grabbed from the NSPs, the inventories, translators, and also we have here a plug-and-play manager driver. So functionalities, interaction with verticals for service overexposure and customization. As I've told you before, the vertical can customize in a way certain parameters, requirements that are in the service. Onboarding and maintenance of VSBs and VSDs in the catalog. Onboarding and maintenance of vertical service instance and end-to-end network slice instances in the status in the inventory. Collect network slice offers from the NSPs and store them in the catalog. Lifecycle management of vertical services which are mapped to end-to-end network slices. Coordination of multi-domain actuation operations for runtime modification and optimization of end-to-end network slices, as I told you before, in the process of the closed control loop for optimizations. And coordination of plug-and-play control instances deployment to expose to verticals customized runtime control functions according to the vertical service request. So to the NSP SSO functionalities, we have, as you can see here, communication service APIs with the DSP, and below we have the communication drivers to the NMRO and to the control plane services that we have in the control plane of the NSP. We have the network slice front-end, network slice lifecycle manager, the catalogs, inventories, and so on. So we can see we have interaction between the DSPs for network slice of exposure, onboarding and maintenance of network slice templates in the catalog, lifecycle management of network slice instance, including mapping and translation of network slice requirements into resource provisioning constraints and operations, onboarding and maintenance of network slice instance status and characteristics in the inventory, coordination of actuation operations for runtime modification of the optimization of network slices, interacting with the below in the southbound with the control plane services and NMRO, and So also the coordination of plug-and-play control instances, deployment to allocate plus slice control and measurement functions. The NMRO functionalities, we have here, this belongs to the NSP. We have here in the northbound interface a communication with the SSO of the NSP. So we have the exposure of network service to the NSP SSO, onboarding and maintenance of network service descriptors in VNF descriptors in the catalog, lifecycle management of network service instances and their associated VNFs, onboarding and maintenance of network service instances and their associated VNF status in the inventory, and enabling network service instance monitoring. So about the network slice information model, also we were very aware of what was happening in the 3GPP, especially network resource model, the technical specification 28541, and the model is built around four main components, which are there related. The stated is a network slice template, network slice subnet template, network slice instance, and network slice subnet instance. All of these are managed by the NSP SSO in its catalog functions, and it's exposed to the DSP to fulfill the end-to-end network slice lifecycle management. Also, we have for the end-to-end service and slices the vertical service blueprint and the vertical service descriptor. These are managed by the DSP SSO in its catalog and inventory functions and exposed to verticals. In terms of technical achievements and prototyping, as I said, the SSO is based on developments and enhancements of the vertical slicer, which is an open source software. This open source software is from a SliceNet partner. It was developed initially under the 5G Transformer project with some add-ons and some modules, especially for the multi-domain and between others, among others, for the SliceNet project. So the vertical slicer is from the Nextworks company. It's public, so it's open source software. You can grab it from this GitHub. Also, the SliceNet NMRO is implemented with open source manual, but SliceNet has also made software models additionally that can run with OSM. So OSM is also an open source software. You can grab it here. We have the NMRO wrapping models from SliceNet and the KOE REST library, client library, which were developed by SliceNet partners also. Also, we are contributing to the standardization, mainly to ITUT focus group 5G machine learning. We have two proposed recommendations now. One of them is machine learning based into network slice management and orchestration, and the other one is vertical assisted network slicing based on a cognitive framework. So these two are on the way to and we hopefully we will have them approved. So we are now proposing these two ones. Let me just show you in terms of orchestration what is happening when a vertical subscribes a service. In the first step, in taking into account what is happening in the DSP, so the vertical goes to a portal, an admin portal. In this portal, it will have access to the services that are available in the catalog. When the vertical chooses a certain service, this request will arrive to the service and slice orchestrator and will start deploying. And first thing that the SSO will do is to decompose the service in the end-to-end network slices. So it knows that you will need to talk with NSP1, NSP2, NSP3, and so on. So the service and slice orchestrator at the DSP will contact every network slice provider that he needs in order to instantiate the network slice, the proper network slice for these services. So the NSP will receive in the service and slice orchestrator, will receive that request, will go to the catalog, grab the proper network slice template, and will communicate with the resource orchestrator to configure the network services that belong to that particular network slice. So the NMRO will deploy these configurations with the virtual infrastructure manager help with on top of the network functions virtualization infrastructure, will instantiate the VNFs that he needs for this service. For instance, in here is deploying the virtual EPC. Then the service and slice orchestrator will contact the QoS control with the parameters configuration that he needs for the physical network elements, for instance, for a certain run of a certain vendor. This QoS control will forward these configuration parameters to the run adapter that will make the adaptation layer for the specific configuration parameters of the run controller of that vendor. For instance, we are using in our test bed, we are implementing a smart grid test bed. We are using the open air interface run, so we need to talk with that open air interface controller and configure the remote radio head below. So in this way, we'll have the network slice up and running, and this will be for mobile network slice, because it's not showing the figure, but our smart grid test bed, for instance, we have for the vertical, we have the IEDs that are the equipments that are communicating between each other to protect the grid. And these equipments will use this network slice, this mobile network slice that was deployed to communicate between each other, to open and close these relays. These IEDs are relays that open and close to protect the grid. We need low latency for that, so we need 5G to have very low latency for them to be able to close and to prevent the power grid failure is spread among several customers and be confined to the minimum possible. So in terms of summary innovation, we have DSP end-to-end network slices orchestration, network slicing multi-domain aspects through the vertical slicer, and the NSP network slices and resources orchestration through the vertical slicer in the OSCM. So these are the presentation that I have prepared for you about the orchestration plane. Any questions?
Thank you so much, José, for such an informative and very clearly explained technical presentation. A lot of work has been carried out on orchestration in the context of slicing in this project. And so thanks for telling us all about the technical achievements and innovations achieved in end-to-end slice orchestration.
Okay, thank you, Jeanne.
So some questions that have come in. First of all, does it use OpenStack, and how is a slice realized? Is it in the OpenStack domain?
Yes, we are using OpenStack as a Vim. Yeah. Well, it's a part of the it's a part of the network slice, because the network slice has several network resources, physical and virtual. And as you can see here, you have the virtual EPC, the VNF on top of the network functions virtualization, and you have the OpenStack that is the virtual infrastructure manager actually. So it will be part of the network slice, yes, for sure.
Okay, thank you for that. Have the new standards worked on by SliceNet been accepted by the standardization bodies and by the NSPs, DSPs, etc.?
Well, this is relatively new, and we are, as I have told you, we are proposing these recommendations to ITU-T. We don't have yet an exception of these recommendations, but as I have told you before, what we have here proposed is something that is common in telecommunications networks. So It's not what is innovation here. It's the orchestration, the vertical slicer, and it's the cognition plane. All the rest, it's usually what we do in telecommunications networks. So hopefully we can have this approved, because I don't see why not.
So the NSPs are on board with them. They're generally enthusiastic about them.
Yes, I suppose so.
Very good. So are the concepts proven and working commercially, or are they in demonstration form?
They are in demonstration, yeah. For the moment, we have 3 use cases in the project. We have a smart grid use case test bed, we have the ELS use case test bed, and we have the smart city lightning test bed. So we are right now we are just in test bed proving concepts.
Absolutely, yeah. Very good. The question there, is the SliceNet instantiated through a trigger device or by the user?
Well, as you can see here, maybe let's go to the vertical. When makes the subscription of the service, this request will arrive to the service and slice orchestrator. So it is a user, actually. It is someone from a vertical that takes the decision of subscribes a service. And upon that, the request will come to the service and slice orchestration, and from here on, it will be an automatic thing that will go in, because this service and slice orchestrator knows that he has the end-to-end network slice templates and the correspondent network slices that he needs to deploy, to contact the NSPs to deploy these network slices in order to have the service, the final service to the vertical. But yes, I should say that it's initiated by a user, yes.
Thank you. Does the DSP orchestrator have a master role and control the NSP orchestrators?
No, they don't control. They are not binded together. I mean, they are not. The DSP does not control. The DSP SSO does not control the NSP SSO. That cannot happen. These are different players, although they can be the same. But usually, for instance, a telecommunications operator, it can be the DSP and the NSP at the same time. But we have the architecture in a way that they can be separated, and so they in that case the DSP SSO cannot control the NSP SSO. Okay.
Okay, very good. And then another question: how do we address the security for slices?
Well, the security, we need to have this in the assurance phase. We need to have the management isolation between the services, and the management isolation between the network slices. So this is something very challenging to be addressed in the security aspects. And there are also some recommendations about that, and we will be, of course, very carefully working on this also.
Okay, thank you very much. I don't think there are any other questions. I think you've answered all of the questions very well. Thank you so much. So I will, unless there's any more, we will close up the webinar. As we have seen today, SliceNet meets the challenging requirements for the orchestration plane, as well as the management and control planes of network slicing across multiple administrative domains. This helps facilitate early adoption of 5G slicing in order for verticals to achieve their demanding use cases. So we will close up the presentation now. The next webinar, just to let you know, is on system integration and demonstration, and that will be on the 5th of May, so please tune in again then.